find it might so much better.
You know my funniest pictures, right? I'm not just like, I don't know if I got my
Okay. We don't want that. We don't want unicorns.
Isn't that right?
Well, have your work packages open. Put your phones away. Have your laptops away. Get everything out. Let's go, 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 go. Go, go, gadget machine. We are Thursday, 10:25. Should have started 5 minutes ago. Why did assembly go late? I wasn't there.
Why weren't you on assembly?
I wasn't here with a student who was worried about their test.
There was just a lot of stuff going on.
Yeah, a lot of
Which
stuff going
student
on.
that didn't go to the assembly?
Pardon?
Which student didn't go to the
I'm
assembly?
not going to tell you. It's private between them and me. I'm a house party, you know.
I think you just like didn't have a student that came in and
I think you just didn't want to go to
yeah,
assembly.
you just didn't go.
That would never be. First of all, being recorded, so that would never be true. Assemblies are wonderful opportunities, and I miss every single one of the last few thoughts that Mr. Patel will have. That sounds like he's not going to have any more thoughts. I didn't mean that.
You know he's watching the stream right now.
Pardon?
You know he's watching the stream right now.
He's probably watching the stream. I think he's probably part of my fan club. Join my Patreon.
You should get a Patreon and just see what happens.
Here, Mr. Neufeld, here's a $5 million bribe. No. It has to be $7 million. Anyway,
But
I need enough for retirement and the inevitable legal fees. Yes.
the legal fees.
Sorry?
For him just giving
You didn't find.
what? You bribe him. So you
Like, if you, someone's going, I can't just quit with millions of dollars and they're gonna be like, where'd you get that?
Why not?
you won the lottery.
Yeah, that's actually publicly available information.
They dug it out.
You're gonna win the Nobel Prize.
You invested into the stock market and came away with a really big sum of money.
You made it back.
I had checked the back table. Like, there was a stack, like a giant stack. Like a huge and gigantic stack. That if it's gone, I'm going to be upset because that's a lot of wasted paper. I had enough for people. Did someone put it in there? Yeah, take it out. Still not as many as there were, though.
This is a big.
Okay, you're welcome.
Want to eat mine?
Okay. Do you need one?
How much did you do on?
Pardon?
How much did you do on?
How much did I do last time?
We did like half
Things.
We did like half the no package.
Really?
Yeah, we did. Well, we didn't do that much. We did the first 3 pages.
No, we did like.
We didn't do this, did we?
No.
Okay. So, a heads up. Number 1, and I put that away. Put your phones away. Put your laptops away. Laptops closed and away. Sophia, closed and away. Stop doing calculus. Calculus isn't important without science to actually do with. It's like art with no subject.
Is math invented or discovered?
No. We do not have time for this.
Is math invented?
Math was invented. The question's been answered. We know
Wait,
that.
can you explain?
No.
Please.
No. 2.
Justify.
No. Moving on.
Yeah.
Moving on. No.
Reflect
This class in particular has a bunch to get through. I am not going to be here on Saturday.
Where?
I have a very good reason that I'm not going to
Where
tell
are you
you.
gonna be?
I'm not going to tell you.
Wait, what
But it's really good reason. Trust me. On Saturday, I am going to post a video. I am going to make a lecture. I'm going to stand here in an empty classroom. I'm going to record something so that you can do it on Saturday, and then if you have time left over, I am going to require you to listen to it.
What if we have questions?
And do it because we don't have time to have another day of just review. We do need to catch up and get on with things. Acids and bases wait for no one. So, I am going to continue. And as a heads up, this section, the introduction to acids and bases, is very much sort of notesy. We have lots of concepts I'm going to reference from Chem 11. It's very theoretical. We're going to draw some things because we have to know what these different things are. So, identify acids and bases through experimentation. We're going to do that a little bit later. To classify a number of solutions as acidic, basic, or nutrimolecular. This is one of my huge screens that I gave you at wasted paper because you probably didn't need all this. Molecular compounds are ones that do not ionize. Why is it up here? That's dumb. There we go. So what kind of things produce ions in a solution? Salts. What are salts? Salts. Where do you get salts from? They are electrolytes, so that do not ionize. Electrolytes would be in there.
Ionic compounds.
Ionic compounds. As well, acids and bases, which I didn't write that well. That says acids. Acids and bases aren't necessarily ionic. You can't necessarily tell the difference, and so we're going to go through a few of those specific. A nutrimolecular is something that isn't ionic and can't produce an acid or a base by any means at all. So, for example, if you have a completely covalent compound, C6H12O6, the biologist in the room, what is this? Sugar. Glucose specifically, and does it dissolve in water? Yeah, totally. It wouldn't be good running your bloodstream if it didn't. So, what does it look like after it dissolves in water? How do you deal with the ions?
Still be the same, right?
It'd still be exactly the same. It dissolves because it has a ton of hydrogen connected to oxygen, so it has a lot of very polar bonds. That polarity attracts the water, lifts it out of solution, and just makes it aqueous as it is. And so if you had a solution that was 100% pure water, and you filled it with glucose, it was 100% pure glucose, there's no ions in there, it will not conduct electricity. If you were in a bathtub in it, theoretically, you could throw in a plugged-in toaster, and it should be fine. Do not try this at home, because why wouldn't it be fine? You have ions, and you're constantly excreting them, and you would end up not being fine. However, this, ionic or covalent? HCl. It's covalent. It is a covalent bond. It's not ionic. It does not have a crystal structure. In fact, this is a gas. If you bubble it through water, what does it become? Hydrochloric acid. And it becomes H plus Cl minus, aqueous, aqueous. And I'll write bubbled in H2O there so that later on you'll know what we're doing. This ionizes. Neutral molecular. If you have something that's already ionic, we don't say it ionizes, we say it dissociates because it's already ions. Yes?
So glucose is a molecular.
It is a molecular and it's neutral. This is not a neutral molecular. This is molecular. Molecular, but it is not neutral. It's electrolyte, and it's acidic. So all the things that are molecular that ionize are acids and bases. And so they will conduct electricity. Hydrochloric acid is a very, very strong acid. It is the very definition of a strong acid, which we haven't done yet. And bases can do this too, except we haven't told you about those types of bases. So to do that, we have to tell you about the type of bases you do know. At any point, wave your hand if I'm going too fast. These are all definitions. We are. There you go. What does it say in the bottom? Oh, it's just a line.
What's that say? Electrolyte.
Acidic.
Acidic, obviously. I can hardly wait until AI gets to the point where I can just sort of wave my hand and it will actually not only text recognize it, but keep the curve and like just make it text around all over there.
I don't know if that'll ever be possible for your handwriting.
Yeah, because it will get to know me personally. I mean, it won't be possible. It will be possible, they just won't do it. They'll do it for advertising because they'll find the one thing that you can't resist buying and they'll advertise. If they can do that, they can do the other thing. They just no money in the other thing. Okay, we are first going to define the type of acids and bases that we've always defined. You just didn't know we did it. And it's Arrhenius. I forgot. Arrhenius acids and bases was defined in 1903. This was a theory of acids and bases. This is the grade 10 theory of acids and bases. An acid was a substance that released what in water? H. Hey, what kind of H?
H plus.
H plus. So, there it is. I'm going to ask some people for their favorite acids and bases. No line, it has to be your favorite. Taylor.
Lemon.
HCl.
Hydrochloric acid, found in your stomach, dissolves things when you eat it, kills all the bacteria. Bacteria that survive your stomach have to evolve quite the protective
What
coat
would
to
happen
do
if
that.
you drank HCl?
Put your hand. It was close. Yes.
What would happen if you drank it since it's already in your stomach?
It would hurt you a lot. Have you ever had heartburn where like your throat hurts?
Yeah.
That's because the acid's coming up and literally burning the lining of your esophagus.
Oh.
So it's quite a strong acid. It can be as low as a pH of 2, 1.5, really quite strong. Kills everything in there. Bacteria that can survive that usually have a really thick mucousy coat. One of the most bad asses of sort of chemistry, biochemistry history, microbiologist, was the discovery that a bacterium caused ulcers. So they used to think that ulcers were caused by stress. All these people who were very stressed out had ulcers, and it turns out if you're stressed, you do produce more stomach acid. It just makes it worse. It's caused by a bacterium, Helicobacter pylori. And so this professor said, it's caused by Helicobacter pylori. And everybody said, that's nonsense. We know it's by stress. You're an idiot. And he said, watch me. He drank a vial of Helicobacter pylori, gave himself ulcers, and then took antibiotics to cure it and said, what up? And then everybody believed him. Yeah. Ulcers are when the mucus lining in your stomach is so thin, the acid is actually burning away your stomach wall. You are not built to take acid. None of your flesh is. You actually have so much mucus there, just like aliens in the movie Alien. The mucus is what's protecting you. Yeah. Sophia, your favorite acid? Excellent. Oh, it's also kind of, oh, hi. Hydroiodic acid, I think that's also a strong acid. Sabine. Or Chloe, because sorry? We're all, okay. Does somebody have one that's not a halogen? Go.
What's the one in a lemon?
No, dude, you can't ask me. What's the one that's what?
It's in a lemon.
You can say citric acid.
Citric acid.
And I like that example because do you know what it looks like? Dylan?
Can we do H2SO4?
Oh yes. My favorite one.
Why
That's
is that
my
your
favorite. H2SO4, it's because it's the first one I burn things with. H2SO4 you can get out of old car batteries. So it's the acid in like a classic car battery. So if you're like young and at home and you want acid to like burn things with, that's where I got it for. Citric acid. Come on. Go, 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 go. No, I don't want to buy citric acid.
Are you sure?
Yeah, well, it literally showed me a preview of what it looked at like, and then, there we go. These are written so poorly. There we go. Here's citric acid. HO to C double bond O to C OH to C double bond O
Can we just write the
OH
formula? Why are we doing this?
to C double bond O OH. That is citric acid.
Why can't we just write it?
Yeah, that's what I'm
What
saying.
if we should write like letters,
What?
like the H, everything.
Oh, sure. You could write it as 1, 2, 3, C4, 1, 2, 3, 4, 5, 6, 7, C4, O7, 1, 2, 3, 4, H4. But that's like 1,000, well, not 1,000, but like 20 different compounds. Because you could connect those carbons in all sorts of different ways. That's the exact structure. Which part of that's the acid?
Can you ask them later about that?
No. Pardon? The HO here, that particular one, is the acid. What happens, this, you had the lecture last day on why not to drink methanol?
Yeah, it's
Yeah.
C407.
Yeah, do it. This is an alcohol
Or
group.
CU4.
By itself, not an acid. But if you add this bit right here, the oxygen is very electronegative. That oxygen is very electronegative. When you put two of them next to each other, this sucks up electrons. That sucks up electrons. So the electrons all get sucked up this way, and that hydrogen just pops off. And then that becomes O minus. So that's an acid. It's got 3 acids on it. Now, we haven't discussed strong and weak acids. It's a weak acid. So they don't all pop off immediately, but it's enough that you get that sour taste, and that's the classic citric taste. If you use a tiny bit of that along with a little bit of vitamin C and a tiny bit of ginger, and you're baking bread and you put it in your bread, you won't taste it, but it'll make your bread last like 3 to 4 days longer because the acidity stops bacterial growth. Don't ask people on a bread making forum what to use as preservatives in their homemade bread. They will yell at you. Pardon?
Okay, wait, so what's
No, it's because I'm a chemist and I made bread, and I want my bread. I would make like 12 loaves at a time, and I want it to last a week, and it wouldn't because it's homemade bread. Go decay in 3 to 4 days, start getting moldy. I'm like, go online. Baking forum. Oh, people who make homemade bread. How do you add preservatives, and what preservatives do you like? And you know what they say? We make bread because we don't like preservatives. Bunch of hippie nonsense. So I researched preservatives, and a tiny bit of ginger works, and a tiny bit of citric acid, vitamin C lasts a whole week. Question?
Tell them?
Wait, so
You
the
should tell
formula
the
for
hippies.
citric
Oh no,
acid-
they were really mad. Like I got banned from the forum mad.
Because
Yeah,
you
like
asked.
I'm banned.
That's so stupid.
Banned because I was not believing, because they're also like, we're all organic. Like all flour is organic. Yes,
Wait, so the citric acid formula is C407H4.
sure, but that doesn't matter.
Oh,
Yes.
Did you get banned because you asked about preservatives?
Yes.
Or because you, so
I-
you didn't get the chance to tell them?
So
that you
no,
had ginger?
no. Well, at first I was like thoroughly flamed, and then banned by a mod. Yeah. I was a troll causing problems because clearly nobody would actually want to know about preservatives. A salt is a neutralization is a neutralization product of an acid and a base. This is classic grade 10 chemistry. Acid plus a base gives us salt plus water. Oh, I didn't do our famous bases. I just wrote in OH minus here because while I was answering questions. So classic Arrhenius, bases give off H plus. Acids give off H plus, bases give off hydroxide OH minus, not alcohol. So that's not a base, that's a base. And some favorite bases. Can't believe I almost dropped the base.
What's a base and
Eric, your favorite base.
Is NaOH?
NaOH is a base. Nice. Dylan, favorite base.
KOA.
KOH, nice. If you say Lithium hydroxide. I will punch you. Teddy.
Lithium?
Yeah. Something that isn't one of the alkali metals, please. Eshwan. Are you on your phone?
No, I was just looking at chemistry thing. CSOH.
What?
Which one?
No, not. You're not allowed to use an alkali metal.
Then you
Oh, I don't know.
use like
Pick literally any other metal.
Use like Mg. Calcium.
Eshwan. Pardon? What?
Zinc hydroxide.
Zinc hydroxide. Right. If it's zinc is +2, so what should I do?
A zinc plus 2.
Yeah.
And then OH minus.
OH minus, yeah. So how many hydroxides?
Like 2.
2. Excellent. Thank you. There we go. So all of those are hydroxides, all of those are bases. Anything with a hydroxide, it has to be a metal and a non-metal. However, there's a common cleaning base that you have used
Baking
in a
soda.
spray bottle.
Hand soap.
Pardon?
Hand soap.
Soap is basic usually because it contains lye, which is sodium hydroxides.
Or is it H2SO4?
H2SO4 is an acid.
Oh, or I meant the other one. What's it called? I forgot. Never mind.
I'm not going to. Sodium bicarbonate isn't. I'm going to save that one for later because it's actually more complicated than just being a base. It's,
Some hydroxide.
pardon? Bleach is not an acid or a base. It's just highly reactive. You'd never mix this with bleach, though. You kill yourself if you mix this with bleach. Well, there's a lot of things you kill yourself if you mix it with bleach. Pardon? Ammonia. Ammonia. So, now's where I get to write ammonia.
NH3.
Does it contain hydroxide?
Yes. No.
No. So that, not Arrhenius base. You know it's a base, so this is already telling you there's a problem with our definition from 1903. That is a base, but it is not an Arrhenius base. It's a Bronsted-Lowry base. Na, give me your favorite salt.
Table salt.
Which is formula? You literally, it's in your name.
MCL,
NaCl, excellent. Now that would be everybody's favorite salt. James, can you give me another salt? There we go. Nice. Oh yeah, we never said hydrofluoric acid, the most famous of the Breaking Bad acids. Felix, one more. Don't use Na.
Okay.
Don't use any of the alkali metals.
CAS.
CAS?
CAS.
S.
Yeah, but you need a 2.
No, you don't.
Why?
You don't? Oh, never mind.
Okay. Calcium's +2, sulfur is also -2. So yeah, you can have hydrogen sulfide, which is technically an acid, and calcium hydroxide, which is technically a base. Put them together, you get calcium sulfide. Essentially, because you can take any metal, add hydroxide to it, and you have a base. You can take any non-metal or negative ion, add hydrogen to it, and have an acid. Then any salt is just an ionic compound. That is not a hydroxide compound. That's all the salts. So any ionic compound that doesn't contain hydroxide turns out to be salt. So, fill in those names. I will just ask you for them. Stomach acid we already talked about. This is called hydrochloric. HNO3 is called nitric acid. I don't know why I didn't give as much room. You need to write the acid part, nitric acid. This is how I blew up my friend's bedroom. We didn't make TNT, we made nitroglycerin, but nitrates are commonly used to make explosives, and they're also used to make fertilizer, of course. which is why the sad story that we told in Equilibrium about the Haber process. He was both a war criminal and probably responsible for more people being alive today than any other single person in history, because the world runs on fertilizer. We couldn't feed our population without fertilizer. As soon as we decrease our use of fertilizer, somebody somewhere starves.
You almost broke in your room though.
Pardon?
You almost broke in your friend's room.
I've told that story at least twice.
No, you haven't.
No.
You never told
You
us.
never told us.
I have a question, Mr. Miko. What's your thoughts on the Apple Vision Pro?
Yeah,
I don't have any thoughts on the Apple Vision Pro. I believe my friends, it is Freedom to Read Week, I think, coming up. There used to be a book that was banned in Canada and the US and actually most of Europe called The Anarchist Cookbook. I possessed a physical, actual copy of said book, which I ordered from a very shady site. Back when I say shady site, I mean I found a address in the back of a comic book that said, if you write to us and give us this money, we'll send you it, and they did. So no websites at this particular time. We got the book, and it was just full of instructions for how to make drugs, explosives, how to phone freak, all sorts of. You used to be able to like take apart payphones, and you could click on them the right way and make phone calls.
You still
In
have it?
retrospect, no. My friend, David Kelch, if you're listening, I want it back, has it.
Can you buy it?
You can buy it now. You can get a really bad copy. The original book like had a nice thick cover. The new ones are just basically look like photocopies. It's not the one you find out or used to be able to find online, which is just nonsense people filled into it. It wasn't the original book. But the original book had instructions how to make nitroglycerin, how to make a variety of compounds. We wanted to make a particular compound. I can't remember its name. But we didn't make it because we couldn't quite get all the ingredients. In retrospect, absolutely fantastic we did not. Because that synthesis progress that I know now, looking at it, would have made cyanide gas. We would have definitely killed ourselves. Because we made nitroglycerin in his bedroom, in an enclosed space, without very much air. So we got all the necessary, we needed hydrochloric acid, glycerin, nitric acid. This is why I am fairly intense about locking the doors and making sure that students can't get into the lab, because we got most of our chemicals from the high school chemistry lab. Got it, made it in his room, made it in a little Winnie the Pooh cereal bowl. And when we were done, we had this clear liquid. So clearly we failed because we grew up on 80s action movies. And so we were expecting a plastic, because plastique was the only C4, you know, those types of explosives. Turns out to make those, you mix it with a solid matrix. Nitroglycerin is a liquid. And we probably didn't make it pure. By Mr. Tate's estimate, he used to be a physics teacher here, we probably only made maybe a quarter teaspoon. And the reason he knows that is because we didn't kill ourselves. After that, we were disappointed by our failure, so to cheer ourselves up, we started playing with flaming saltpeter. Saltpeter is one of the ingredients in gunpowder. We also make gunpowder. So we have this, it just snap, crackles, pops, so we have it on a bit of tin foil on his room, and we're lighting it, and it's going snap, and a piece of it crackles out and lands in the Winnie the Pooh cereal bowl. And immediately the loudest sound I've ever heard in my entire life goes off. Just boom. The entire house shakes, ceiling panels come down, and there's a ring of fire around his room. Because the cereal bowl had melted and exploded, and it's stuck to the wall, and pieces of this is stuck to the wall, and it's on fire. We're not on fire. Every piece missed us. Every single piece. We're just lucky. So his dad was very safety conscious. He was like a safety person, like for a logging company. So he had like extra safety equipment around. He had a pile of CO2 fire extinguishers. So we grabbed a few of them, put the fire out, and at this point we should have also died. Why? Too much CO2. We filled the room with CO2. However, the first time we put it out, it did not go out. It relit because it contains its own oxygen. It's not feeding itself from the oxygen in the room. It's just feeding itself. So we put it out several times, and once I think it got cold enough, it stayed out, and then we went outside. If we'd stayed in that room, I'm pretty sure we would have died, because there's no oxygen left in the downstairs basement at all, so as far as I can tell. Yeah.
Why?
Yeah.
Every time you talk,
Yeah,
every
like
new
that
story, I'm
Yeah.
like, how are you?
So we waited for it to go out. We went outside for a bit. We're like, holy crap. We go in later. He's got burn marks all around his room. So we're like, crap. We go to town. And we just buy new posters and put them up so his parents don't find out. Now, that was dangerous.
How'd
But
you get rid of the
at this
white
time,
stuff?
we were also making coffee tins, so we were making bad gunpowder, filling a coffee tin with gunpowder. We bury it in the ground, and then if you've ever fired model rockets, you know they come with an igniter and a long cord. We'd put the cord in it. One person would stand back and light it, and the other person would stand on top of it, because the ground would buckle, and it would throw you like 3 or 4 feet. It was like a ride. It was hilarious. In retrospect, if we had buried it a little too high, that coffee can wouldn't have buckled the ground. It would have shot shrapnel up and hit us, and we would have died because we were making grenades, essentially, or landmines. And that happened a couple of times when a piece came out, and we were like, oh, we better be careful. We were
How
in
did
it.
you even come to this conclusion? Well, if I buried it in the ground, it would throw me. Like,
Well, the first time we set it off, we were worried about safety. So let's bury it first and see the explosion. And the ground, we buried it so deep, it just went like this, and we're like, that'd be cool, let's stand on that. I also want to really heavily emphasize, when I was young, I didn't have internet, and I didn't have like a cell phone or video games. I grew up on a farm. I had access to liquid nitrogen, gasoline, and fertilizer. I will say that those things are very entertaining when you don't have anything else to do. Lots and lots of gasoline. Basically, yeah.
It's gonna be like a really interesting live stream.
If you take a little bit of gasoline and you put it in a metal container and you shake it really well and then you light it from a distance, that is the loudest bomb you'll ever hear. Because you know those hydrogen oxygen balloons? Boom. Pardon?
Louder than an actual bomb?
Well, I've never heard an actual bomb. Other than the ones
we
I've
used to dump gasoline in the sandbox and then light it.
Yeah, see, fun.
Yeah, and you could like draw stuff with it. It was great.
how is it alive? How are you alive?
I made a giant pentagram in the middle of the road and then stood in the middle of it and lit it on fire.
When did you?
And I want to say that it turned out that was the safest decision because I was a little scared. I'd used so much gasoline, you could smell it everywhere. By the way, if you're using gasoline, one of the most common ways for an arsonist to die is because they get it on their hands and clothing, and when they light it, they light themselves. I am so lucky I'm not dead. But when I lit it on fire, I was standing in the middle of the road, and when I lit it on fire, the ditches exploded. Like whoosh, and there were like burning bushes all along. Gasoline burns. Gasoline vapor explodes. And while I was debating what to do, the vapor is just filling the ditch.
Oh, yeah.
My first thought was I should stand in the ditch because that would be safer. I should be further from this away. If I'd done that, I would have badly burned or killed myself. But because I decided to stand in the center and the road was raised, the vapors were going this way, so it actually turned out by accident to be the safest place to be. The moral of this is not you should do dangerous things. It's when your kids are your age and younger, watch them very closely. They are going to do the dumbest things you can possibly imagine. My brother lit a candle in a hayloft.
How'd that go?
My mom tried to play gypsy in the closet and had candles right underneath clothes.
Yeah, should have died. Should have died.
What's
Like,
gypsy?
plastic bags on
Like-
fire because the
just like a
plastic would melt and
fortune
drop
teller.
and make
Like
sound.
crystal ball.
Side note, did you grow up
Yeah.
Mennonite? How did lighting a pentagram in the middle of the road work out for you?
That's not a sin.
What was the, yeah, well, like, what was
Well,
the-
I was also in my edgy teenage years.
Yeah.
Yeah.
How that work
I
out?
seriously considered being goth for a while just because I knew it would.
Did anyone like see this? Like
What does that say?
what was the goal?
Wait, why did you consider?
Oh, that was just because it was cool. Like any metal album you've ever seen. That would be cool. Yeah. Also, 80s. You've all seen Stranger Things?
Yeah.
Playing the guitar on top of the thing.
Show us
He's
it.
not goth.
Pardon?
Oh, you mean with like his hats?
Well, no, he wasn't goth, but in metal. Flaming pentagram. Playing guitar badly would have been cool.
Did you play guitar badly?
I can play it very badly.
I can play it.
I was actually in a band, and I'm proud to say I don't know how to play guitar at all, and it didn't matter. NaOH. Just so that you're aware, vinegar is any one of these. What? This. What the heck happened? It's because even my shirt sleeve will make that react. This is a bad writing of it because that could be anything. This is for the inorganic chemists that like putting hydrogen in the front. It doesn't reflect its actual structure. It's kind of stupid. Inorganic chemists love to do it. This is the proper structure. And the reason that's the proper structure is that CH3, it's C double bond O, OH. Anyway, I've thoroughly distracted you. Stop that. This is an acid. That's vinegar. That's what you find in there. And that is the reason why alcohol eventually gets converted to in your liver, and that's relatively non-toxic, and your kidneys can get rid of that, which is why alcohol is only a little toxic. Methanol goes to that, but it goes to only a 1-carbon version of it. Formic acid, ant bite, kills your nerves, and you go blind and then die. Bases. Sodium hydroxide is also known as lye. If you've seen Fight Club, they mix it with a special kind of fat to make soap. Any base plus fat makes soap. Because you take the fatty acids, which have a long... How many of you are in Biology 12? A few of you? So you've done fatty acids? Yeah. So you know a fatty acid is like C double bond O, OH with a big long hydrophobic tail? Do you do soap? So you... Oh, okay. We already did that. I forgot if I did it because same topic on this page. Very, very caustic. We also use it to clean the inside of your butt oven. It will just rip organic things apart. What?
You said butt.
I wasn't going to say
You said
butt.
clean it.
It's on live stream.
It's on live stream. It's very corrosive. Do not use it to clean your butt. Because if you use it to clean your butt, you will not have much of a butt left. Yes, Eshwar.
Is it vinegar or acetic acid?
It is acetic acid. So vinegar, its technical name nowadays is ethanoic acid. Its old names, you'll still see it labeled by a lot as acetic
so
acid.
That's the
Same thing. Yeah.
And is the formula and stuff still the same?
Yeah. It's because this is known as an acetate group. That's acetic acid. And so 2 carbons used to go by acetate. And then they changed it into the standardized methane, ethane, propane. And so they changed it to the ethanoic. But lots of people still call it acetic.
Okay.
Used to make soap. Very good cleaner. Drain cleaner, if you have lots of organic crap in your drains. A lot of the drain cleaner, you're just putting down various forms of almost pure sodium hydroxide. Don't get that on your hands. It will also rip your drains apart if you let it. It can generate a lot of gas. And so it's also very hard if you have your own sewer system. And so you are on a system in which you have sewage coming out. It's not going out to the city or anything. That might actually destroy all the bacteria that are in there. And now all of a sudden you have problems with your cesspool. NH3 is ammonia. This is a non-areneous base, known as a Bronson-Lowry. It is also toxic and corrosive. If you were to smell ammonia and then you suddenly stop smelling ammonia, you need to run as fast as you can because at its lethal concentration, it burns out your receptors' ability to smell it. So the point at which you don't smell it anymore is the point at which it's killing you for sure. And that's what I learned when I worked at a factory that produced giant containers full of ammonia.
Isn't that what smelling salts?
Why'd you?
Smelling salts will have that too because it's a very pungent smell.
Why'd you work in a factory that made ammonia?
They made it as part of the extraction of nickel process. It was in Alberta, and they took nickel ore, and ammonia was part of the extraction process. So they had vats of it.
Is ammonia the one that smells like rotten eggs?
No, that's dihydrogen sulfide, H2S, is
Oh.
what smells like rotten eggs. This is just a, this, have you ever been like in a chicken coop or a farm where there's lots of urine? That really sharp smell is ammonia. Which is why they fought wars over bat caves. Because before we had the Haber process, the only way to get ammonia was to make fertilizers and weapons was to get the guano that had built up. I don't know why that page is there. On to the next one. Bronsted-Lowry acids and bases. This is a more general theory, and it's known as the proton transfer theory. Hold it. I think I do know why that's there. That's a quiz. Dun, 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 dun. Is it? Oh yeah. This is an unfair quiz. It'll allow me to discuss some upcoming things. Just try your best. Excellent. Get out your phone or laptop and answer the following questions. You do not have to give your real name. You go to hellosmart.com and you type 897683. Let's start that sucker going.
Wait, where do we go?
Hellosmart.com. Right there. And you type in 89763. Is Theo?
I can't connect to the internet.
Anyway, you can use whatever name you like as long as it's appropriate. Yeah, I know. But I said you could use any name, so
Oh.
somebody's clearly using his name. Or maybe their name is secretly Theo.
What's that password?
Doesn't he have a quiz? It counts for 10% of your mark today?
Right now?
Yeah, hellosmart.com, 897683. Go, 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 go.
What the hell? 10% of our grade.
For today.
For today.
For today.
What was the other 90%?
The rest of the notes.
These notes?
Yeah.
Oh. It's basically like worth
These notes. These notes. Oh.
What's the thing called? Hello Smart?
Hellosmart.com.
Hey, the question doesn't show. It's glitching.
Oh,
Whoops.
I can share my phone? Okay.
Hello. Yeah. Hellosmart.com. I haven't used one of these for ages. Someone's actually me. There's 3 me's.
Let's see. Well, that's not. What does that mean? Join this. How come my name? Join. Okay. What's my name? Oh, my name. What's
You
my
join
name?
as a guest?
How do they spell that?
You just give a name, type in that code.
What's the code?
897683.
Yo.
That's the ID.
Oh.
The ID is the number.
897. I barely see it. 68.
Wait, is it? Oh, it's definitely.
Two days out. Okay, let me check. I don't think this. Wait, is that how you say it? It's in. Wait. Toodaloo.
There we go. This should help you think.
This is, yeah, this is. Oh, it's Kahoot.
Which of the following is correct?
cahoots. They're too fun.
Okay.
Why?
This is like
Is this time?
oh, that's what is it?
What's the dream cleaner?
Does an acid react with zinc?
We should do
I
this
think
more.
I'm gonna go with this.
Acid react with zinc.
Yeah, it's smaller than 7. No way. 'Cause it doesn't produce.
Bro, Eric is
Eric
so
Ross.
slow.
I know.
Eric,
Eric Rose.
wait, that's actually, oh, we put Eric together.
That's getting a little tiresome. Let's go with
How do I? How much is the face? I don't know what's drink HCl, no.
there we go.
Whoa.
We're almost done. This is called Netflix.
Disco version. 80s.
Oh, who is?
Wait, I think I got the first one wrong.
Okay, how close are we? Got 91% done.
Dylan isn't me.
Too loud. Finish.
Wait. How am I supposed to know that? How am I supposed to know that? Wait.
Just
Is
click
it
things.
only common acid found on the side?
It's not for marks, just click things.
Let's go, Dylan.
Submit all answers. Submit. Great job.
Okay, who's left?
Why are some of them red?
That was
No
last.
one
I don't
was
know.
playing Hayden.
Press egg.
Apparently Theo's not here, so I'm going to end it. Is anybody not done that needs to finish?
No, just
Okay,
There's no winner possible.
end. Take away the music.
I got it wrong. Wrong.
What is a characteristic that is common to bases? Whoa, 10 of you picked A. They react with metals to produce hydroxide. No. Bases are metals with hydroxide. They don't react with metals to produce hydroxide. They are metals with hydroxide. So like NaOH, they produce a yellow color in bromothymol blue solution. Here's the introduction to the thing that you probably haven't been using.
I was like hovering over the
And you had in chemistry 10, maybe or maybe not 11, but you now have a page in your book of all the pHs and all the colors these things do. So you can go to bromothymol blue. Is that the one that's on there more than once? No, it's there. And if it's yellow, that means it's acidic.
Oh.
So you had to know about a table I hadn't referenced yet. Oh, too bad for you. And so that one doesn't work. They produce hydroxide solutions that are tiny. No, they produce hydroxide solutions that are large. This is 1.0 times 10 to the minus 7. That is literally 0.1, 2, 3, 4, 5, 6, 7 molar less than that? That is not a very good base. However, this one's a bit tricky because that doesn't reference hydroxide. It just says the amount of acid. So one of the things to introduce at this point is that if you are neutral, what pH are you? 7. pH is equal to 7. How many of you have done logarithms in math? Is there anybody who hasn't done logarithms? Excellent. NA? You put up your hand for neither of those things. Put away your phone. If I have, did I do this last day? What is the log of 10? 1.
You did this last time.
It was 1. Boom, boom, boom. So the pH is equal to the negative log of the concentration of H3O plus. And pOH is equal to the negative log of the concentration of OH minus. And the pH is equal, no, I won't do it that way. pH plus pOH is equal to 14. So if the pH is, say, 7, then the pOH is also 7. Their concentrations are equal. If it's acidic, if the pH is equal to 3, the pOH is equal to 11. And that tells us that the concentration of OH minus would be equal to 1.0 to the minus 3. So that is 1.0 times 10 to the minus 11 is very small, whereas the concentration for H plus is equal to 1.0 times 10 to the minus 3. Quite big by comparison. So as one goes up, the other goes down. They're never 0. So another way of saying that a solution is really basic,
It's saying that acid is really small.
yeah, is saying that there's hardly any acid there. Oh my goodness. I didn't know I'd have to reload. So, trick questions, and they weren't fair, I know. They also will be doing this more explicitly, but also just as sort of a general qualitative flavor. It's helpful to know that as we're doing this other material. Now, some of these, which is the common substance found in solid drain cleaner, I did mention it, I don't know if I wrote it down in the notes. But drain cleaner is sodium hydroxide. I must have did it because only 2 people got that one wrong and 2 people didn't answer. Nobody got this one. Which of the following is characteristic of basic fluid? Again, you have to use this. Also, I might be wrong, so let's see. They turn bromocresol green. Bromocresol green in basic solutions would be blue. So that works. What reacts with metals to produce hydrogen gas? From last day. We did it up there. I think I might have burned myself. Acids. Acids plus metal make hydrogen gas. pOH greater than 7. Well, again, if the pOH is greater than 7, that means it's acidic. They accept hydroxide ion. No, they give away hydroxide ions. 4. What is the following describes an acidic solution? Litmus color is red and it reacts with zinc? Yeah. So even though on the other one, most people didn't, some people selected that one for bases, that is absolutely true with acids. None of those other ones make sense. And hydrochloric acid is found in the stomach. Well done. Some of you think it's nitric acid, even though I misspelled acid. You cannot build bombs. Well, actually, that's not quite true. You cannot easily build bombs out of the acid in your stomach. It is hydrochloric. Good. All the way back here. Yes, you put it in your bag. Okay. In the proton transfer theory, an acid is something that donates a proton. So it is a proton donor. We stop referring to them as H plus. H plus and a proton are the same thing. But we want to think of it is that because it's a naked single proton. It's got no neutrons. It's got no electrons. It is a proton moving back and forth. That's what hydrogen H plus actually is. And so a base is anything that accepts a proton. So now we could explain NH3 plus HCl goes to NH4 plus plus Cl minus. It will accept the proton. There's no hydroxide here. It's still a base. And I put that in the wrong spot. Crap. Nobody saw that. And I did that, and there, fixed. Just do that on your paper if you started writing it. I'm sure that's fine.
Bro.
Proton donor, HCl
Wait.
goes to H
So
plus.
That example thing? Wait. Oh, wait.
There
oh,
we
I
go.
got it. I got it.
Yeah,
Yeah, he moved it.
I moved it. No, I
Yeah, I
didn't.
didn't get to that.
It was like that all along.
You'll check the last
That was
piece.
slow.
And now is where I also get to tell you, in science class, which I'm sure you've heard before, you know when your teacher has said that an acid is H plus,
Yeah.
every single teacher has lied to you. That does not exist in a solution. There's no such thing as H plus. H plus does not exist. H plus is too attractive. If H plus walks into a room and there's water there, it will immediately, I think the word I'm looking for there is protonated, attract water. It's so attractive, if it walks into a room, it has a partner. That's why I wear a lab coat. If I walked into any room in a Speedo, partner.
What?
That image is now in your head.
No, no.
No.
Mm-hmm.
That never.
Please scroll
What's that?
What's that say? Protonated?
Protonated.
What's that mean?
It means it's got a proton.
Well, what's the native form?
Oh, he added to. What other rooms have aided in? I can't think of any all of a sudden right now, but that's like a normal English thing. If you've been Newfoundlanded, protonated, what other words use that? Hydrated, added water, that works. Oxygenated, added oxygen. Protonated, added proton. Carbonated, added carbon. Yes, now we're thinking of it. So protonated, added proton. The reason is because I'm now going to draw. We have water, and water does everybody remember the slightly positive and slightly negative signs from chemistry 11? Lowercase delta, not a full +1, a little bit less. Polar bond, and we have what charges on the oxygen? Slightly negative. It's got a couple of lone pairs there, right? And over here, we have a naked hydrogen. I really should unlock that door, because everybody's been locking themselves out. This hydrogen doesn't have its electron. It's a single naked proton. It has concentrated that positive on a very tiny nucleus. It is very, very attractive. It is not wearing any clothing. Again, Mr. Neufeld in a Speedo. So that is so attractive, and water here has large amounts of negative charge, just sitting there, attracting that positive charge. It's also slightly negative already because of the it's very electronegative, and so that hydrogen is like, hey, how you doing?
kind of scary.
Mm-hmm. Don't worry. Consent was involved. Water picks up everything. Colored that the wrong way.
What? Where are the arrows coming? Oh, from that.
Still doing it wrong. So hydrogen doesn't have any electrons. It notices the electrons on the water. It says, hey, how you doing? And water said, I've been looking for somebody. And now oxygen there now has 3 partners.
Could also have
H3O.
4.
So it's H3O plus.
It could also have 4.
Pardon?
It could have 4.
It doesn't do 4. That's a little too much even for oxygen.
But it has like 2 extra electrons there.
It does. I don't think it ever actually, like, I think chemically that just, it's not quite electronegative enough. It can't quite hold on. 3 partners is a lot. It's got to juggle all of those, date night, 3 different ones, making sure that they're all well bonded, happy. 4th one, just can't keep it together. Having had to keep 1 happy, I can't even imagine 2. So overall, H plus H2O goes to H3O plus. This is known as the hydrated proton, and its name is hydronium. So whenever you see H plus written in a formula or written as a reaction, it is never actually H plus. It is H3O plus every time, because that's just what it is in solution. It's just, for simplification's sake, you can write it as H plus and do all the reactions because the water comes on and off as it reacts. So you can ignore it, but you should also know that that's what it actually is. Yeah.
Oh, do we ever have to worry about molecular geometry
Not too much, because of course this isn't actually flat, this is a 3-dimensional thing. VSEPR has not been a mandatory part of the Chemistry 12 curriculum in a while. I still try and do it in Chem 11 if I can, but I don't often have the time. If you're an AP, they even do less than they used to. But I will say, to fully understand a lot of the reactions as you get on, knowing the 3D structures is what eventually allows you. Because how things approach each other and how they're directed 3-dimensionally is how they react. Especially when you get into enzymes. Not yet. But it would be a tetrahedral, except the tetrahedral would be part of that, and then that would push them down, so you'd have some sort of pyramid. Nope.
There's another empty page.
Yeah, I don't know why that's there.
No quiz. I think it's a
No quiz for that one. I was going to have you... Oh! This would set us up. We only have 10 minutes left. No, we'll do this first. Hydrogen. Electropositive or Dylan's phone?
Oh,
Dylan, hydrogen, electropositive or electronegative?
it's electropositive.
It's electropositive. Where's the most electronegative things in the periodic table?
It's in the bottom left corner.
Electropositive or electronegative?
Oh, sorry. Bottom right. Yeah. Top right.
You're better here.
Top right.
Top right.
Yeah.
So this is the most electronegative. This is the most electropositive. Hydrogen isn't the most electropositive, but we often put it here because it is quite electropositive. It could go here, hydrogen can gain an electron and become the hydride ion. It doesn't do that often. Most often it acts and gives away that electron, becomes H+, so it's much better here as electropositive. You'll see periodic tables where it's more. So electropositive side, electronegative side. So what makes a good acid or good proton donor? So what makes for a good acid? So we have to consider that hydrogen is electropositive. And we want something that's willing to give it away.
Is that one word, electropositive?
Yep. Now, it's electropositive, it's in a covalent bond. We want that bond to break. So what would the other atom have to be? What's going to steal its electrons?
Electronegative.
Electronegative. So we want a place with an electronegative. A reminder from grade 11, the amount an atom pulls on a bonding or shared electron. To distinguish it from ionization energy, which is a very similar force, but they don't have to be bonded in that particular case. So if we put it with something electronegative, they're going to have that tension, and that way is when they break up, inevitably, because opposites don't actually attract in the long run. They always break up. Then the electronegative one will run away with all the electrons, and hydrogen will be left there with a very, very concentrated charge. To interrupt that prelude, we're going to consider what a proton actually is, because it seems obvious, but I want to be very clear. I want you to draw the Bohr model for hydrogen. How many protons do we have? How many electrons? And now we have hydrogen. That's called monoatomic hydrogen because it's not an H2. Most of the universe is filled with monoatomic hydrogen because they haven't gotten close enough together to make H2. Someone ever says, Mr. Neufeld, what's up? I say, monoatomic hydrogen. Because no matter which direction you go from planet Earth, if you keep going in a straight line, eventually you'll find yourself in the depths of interstellar space. And the only thing around you will be a speck of monoatomic hydrogen every few light years.
Wait, so there's like nothing in the air?
And not in interstellar space, no.
I don't get how that's even possible. There's literally just nothing.
Just nothing. That's what a vacuum is. Space with no atmosphere, no molecules, no
Apparently,
nothing.
like when you're in between like the galaxies and there's nothing there, you can't see anything.
Right, because
It's black.
well, there'd be light if you're still you could see the galaxies, but other than those particles of photons, there's nothing else there. Yeah.
I kind of want to be like in interstellar space.
When you consider your future, always shoot for the moon, because even if you miss, you'll be left floating without air or oxygen in the depths of interstellar space. Now, I'm going to take its poor electron away. What's left? Particle-wise, what's left? One single proton. So we have a proton. Now, this is where my model here, because I'm trying to tell you something and I can't draw it. How big is this distance? Is it relatively large? Small? Is this to scale?
Very large.
It's very, very large. In fact, if I made a dot, and I do this to give them an idea of scale in Chem 10, I need a small dot. There we go. Very small dot. That's the size of the proton. So let's say that's the original size. How far over would I have to go for the electron?
3 whiteboards.
Pardon? 3 whiteboards. Well, that would be off the screen, so I'll need a pencil. I need a pencil with some lead in it. I've been told that these are terrible pencils. So, pencil. Draw a dot where the nearest electron is.
What's happening? What does he mean?
I believe.
Means that he's not where it is to scale.
Oh, I see.
That's a proton, and then that's how far away the electron is.
He's like very.
He's just hiding.
He's standing behind the door for sure.
Yeah, he's like.
He's gonna show up behind us.
You shouldn't be wasting his precious 25 seconds.
Let's go.
Just hide behind the door. Let's probably keep it curious then. I think he can do it for our new lunch. We'll say your kids are more luck.
What is
I just ran 3 football fields away,
What?
and on a tree, there's a pencil mark. That is how big the atom is compared to the size of the nucleus. So if you have an electron, you have that dot, 3 football fields away is the nearest electron. So most of the atom is empty space. This is why theoretically we should make our hands be able to move through our other hand or through the table. It's mostly empty space. The fact you can't move through it is wild. Like you should. The only reason you can't is because that repulsion between electrons and electrons, it's the negative charge against the negative charge, is so strong that you just can't. You never, that's the whole, like, you never actually touch anything because it's just electron repulsion.
Wait, so do you not actually ever touch anything?
No, not in a classical.
What if you did?
Touch kind of
What
way.
if you did actually make it?
Yeah, I did that at the Tri-University Meson facility at the University of British Columbia. It's called a particle accelerator.
Oh, when you
And you smash them together, and then you make new elements. So,
The electrons, not the electrons.
so this, even though this is not to scale, I want to really emphasize,
Wait.
this is very tiny. And it's much smaller than any other amount we've ever seen. Even for lithium, the next smallest one with the +1 charge, it still has like an entire electron layer in there. The 2 electrons that are not its valence electrons. It's still, by comparison, massive. So this charge is very, very concentrated. So it is very small. It's a concentrated charge. And that is what makes it so different, and why acid-base chemistry exists, is because that hydrogen is just so attracted to other things, because they're also very attracted to it. That amount of charge in a small space just makes it more powerful. Yes?
Do you think if the atoms like lined up correctly, you could put your like hand through a table?
Yes. In fact, you can actually calculate the probability of that happening. It's very low, but there's a chance that that could happen.
And then what would happen if it went through? Would you be able to take it back out?
Well, the thing is, the chance would have to repeat itself as you moved. So even if it happened for a second,
Oh.
you would then be
Stuck in the
stuck in the middle of the table, and then all these nuclear explosions would start happening as your atoms started to fuse with the atoms of the table.
Nuclear
So,
explosion.
yeah, because you're
So
you're
like
now
nuclear
atoms
bomb
within
is
atoms.
just
Yeah.
basically-
Has it ever happened before?
No, because we observe it, and like the odds of it happening are so low that it makes the length of the age of the projected age of the universe look small.
What the
What
heck?
if you just take like 2
Okay, so what if it
one
actually
atom?
ends up happening?
Well, if we take 2 atoms
There's gonna be a nuclear
and we make them hit each other really, really hard,
That's just in the particle.
that's a particle, then you can do that.
What if you take 2 sheets of atoms?
So if it's
You would need a really, really big particle accelerator.
Aren't they trying to make one of those? Like they're trying to upgrade the oldest.
Yeah, it's not usually about making them bigger, it's more usually about making them more efficient and have less radioactive byproducts. Before you go, so, concentration is another way of making the charge larger. I guess that will be the last thing I say before we go into that. So, on Saturday, you will have a link on your classroom to do the next material.
Why doesn't this just put it up on TV?
Okay? So bring headphones, and then when you're done it, you can work on headset.
Mr. Needle, wouldn't it be wild if just sometimes you just get your finger stuck in it?
Yep.
It's just, you're like, oh,
Oh,
yeah.
and it just sort of formed around it. Yeah. This is why
That was just part of life.
whenever they have like in a by either magic or technology, people like blip out and blip somewhere in. What happened to the air that was there? Because if you fused with it, you're now an exploding nuclear bomb.
No, I got replaced.
But if it got displaced, like it got moved, there should be a thunderclap.
No, like you make like a vacuum.
Oh, if it swaps, that would deal with it too.
You make like a vacuum and then like
Questions about some.
so then when you appear, it's like you're hearing the
Oh, so I'm assuming that's soluble, and you'd look up the KSP of copper iodate. Did you do that? Okay. You look at it, up at it. You would then calculate the trial KSP, which would be 4x cubed. No, look. So you would take that times that squared, and you calculate it, and then you would just compare it. If it's larger, then you get a precipitate forming. If it's smaller, then you wouldn't. And so the one that says larger and precipitate forms could be right. The one that says smaller and no precipitate forms could be right. So the only possible answers are A and B. And then from that, you'd have to do the calculation. Show you the split?
Yeah.
Oh, that's your solubility table and your KSP table. So you look up which one of those is soluble, that's most soluble, and then next, and the other one. So,
So the lowest one would be the smallest concentration.
yeah, so if we look, where is it? So is any one of those actually just plain old soluble? So sulfate, copper sulfate soluble. So that should be first.
You have the whole weekend to like.
So only C and D could be correct. Calcium soluble
No, I literally can't.
and barium soluble. So sorry, low solubility. So they're next, but then you have to flip and go.
Which one has the smallest?
Which one is the smaller or larger? Because the next one is the one with the larger KSP. So calcium sulfate is there, and barium sulfate is there, and that one's so that one's more soluble. So it'd be calcium and then the barium. So it'd be C.
And then this one here, this last one.
Fixed flask of their one. What equilibrium? When equilibrium, the pressure has increased. So if the pressure's increased, which way did it shift?
It could be.
No, the 2 particles on that side, 3 particles on that side. So
Okay.
had to, if the pressure went up, it shifted right. If it shifted right, that means the amount that we put in there, it's products over reactants.
Okay.
There was too much reactants.
Yeah, yeah.
That means it was smaller, so it shifted right because the trial KQ was less than the KQ.
Okay.
That had to have been true.
All right.
Does that make sense?
Yeah, that makes sense. Yeah, that makes sense. Cool.
Question?
No, I don't think so. I can email you questions. Right?
Yes, and I'll be around this afternoon. I'm gone this weekend though, because I'm not here on Saturday, and I may be gone Sunday too. I may be around Sunday afternoon, I don't know for sure, but I am definitely around tomorrow tutorial, and today, this afternoon. What sports do you have?
Fitness performance, so ends at 3.
Oh, you can come over at 3. I'll be there.
Okay.
Privet House.